Good morning and welcome to the second virtual Big Day. I'd like to begin by acknowledging the traditional owners of the lands on which we meet today across Australia. I would also like to pay my respects to elders past and present. My name is Shorju Dasaman, an intern at the ACS Foundation, and I will be your virtual Big Day In co-host for today. The Big Day In is an IT careers conference in an online format this year, aimed at giving you an insight into where a career in technology can take you. Today, we'll be hearing from two insightful presenters, Dan Bowen from Microsoft and Nursin Malki from Westpac Group. If you have any questions for the presenters, submit them during their respective presentations by clicking the Ask a Question button on the bottom right-hand side of your screen. Questions will be filtered and asked of the presenters at the end of their presentation. Dan Bowen is a technology strategist at Microsoft. He works with people to get the most out of technology and help them look beyond the horizon to help them plan for the future around AI, mixed reality, and more. So please join me in welcoming our first presenter for today, Dan Bowen from Microsoft with Machines, AI, and Future Skills.
Thanks, Shorju, and hi everybody. Thanks for tuning in to the Big Day In virtually this year, which is fantastic. Yes, I'm Dan. I'm a technology strategist at Microsoft. So that means that I look outside the box across all of the Microsoft stack and look at customers and see how they are preparing themselves for the future, whether that's to do with their training, their technology, artificial intelligence, or any of the things that we might be doing. And today what I'm going to do is look at some of those trends and just some of the really cool things coming up from quantum computing to AI. So let's think first of all, though, when you are preparing for jobs of the future, what are the big challenges that we've got in the earth? You know, some of the three things that we've got, global challenges, are including climate change, food production, and obviously the resistance to antibiotics. These are three big things across the world that everybody is kind of focused on. And these are big challenges that technology can kind of resolve. Now, when you're listening to this, you might be thinking of technology itself, but think about always think about the actual achievements that you can do with that technology. So a vet, a doctor, a health worker, somebody who's interested in agriculture, everybody will be using technology in a different way, you know, from today moving forward. This is probably, this point in time is the slowest the internet's ever going to be, the worst the technology is ever going to be. It's only going to get better. It's just really important that we think as technology gets better, what jobs are going to be created, and then also what big things can we actually solve for the planet. So what are the engines of your future? What are the things that you need to be looking at? And from a Microsoft point of view, but from our other vendors as well, who will be talking today and through the other Big Day In presentations. The big things that you're going to be utilizing and already are utilizing, but you might not know it. Artificial intelligence, the use of machines and technology to learn and actually solve solutions for you. The Internet of Things, the small devices, the fridge being connected to the internet, your devices around the home being connected, your watch, your Fitbits, all of the tools and technologies that we got, we call that edge computing, things right at the edge of the devices. So also we call it intelligent edge. So have we got AI inside those devices right on the edge? So in around the collar of a leopard, for example, or under the sea, in a tracking camera for fish, lots of things like that, right? Really edge computing use cases. Then mixed reality, the way that you can actually merge the digital and the physical worlds, and we look at that a little bit later as well. And new technologies such as blockchain, and I know we're going to get a talk later on in this session about security, but blockchain's quite an interesting one as well. And then quantum, which we look at in a second, which is going to change everything. So let's look into the future a little bit and kind of really try to inspire everybody listening in today. When we look to the future, we think data centers. Cloud is where everything is going to be. Lots of different clouds out there. Microsoft's cloud's called Azure. This is all like AI and things happen. But it's not that fancy. It's basically our computers in our data centers that you can run things on. But what that does mean is that we can create things like supercomputers. We announced last week that we've got one of the biggest supercomputers in the world now, basically based on joining lots of these computers in our data centers together. And that's really important for everybody, because what that means is similar to when we think about, say, cars, you know, high-end cars and things in Formula One, things that they use in some of those technologies and in those cars come into everyday technology as well. So into our own cars. So collision detection started in Formula One, and now we've got it in our Toyota cars and cars that we've got every day. So a lot of this supercomputer power, you might think, well, that doesn't interest me, but it does, because it'll connect in and allow you to use these things at scale very cheaply. Another thing to think about as well, when we're thinking about hardware, I've put this little logo in the corner here, xCloud. So at the minute, hardware, if you think about it, you might have got an Xbox, you might have got a PlayStation, but where we're moving with those devices, you know, to save you buying an Xbox and the latest and greatest GPUs every year, we're moving that into our data centers. So you'll be able to stream your Xbox games from the cloud. So that's a really, really cool thing as well. So utilizing compute in other areas, in our data centers or other vendors' data centers, is something that you really need to start thinking about. So thinking about how you learn those skills is really, really important as well. So this is what our data centers look like. You just push these racks in large containers and we push them into our data warehouses. But the interesting thing is we've got to think responsibly about this, because it's taking away the electricity needs from your point of view or customers' point of view. So they don't need PCs and large servers on site because they're using ours, but it does take a lot of electricity. So it's really, really important that we're thinking socially about how we use technology as well. So this is something we've done recently called Project Natic. And what we've done, we've put our data centers underwater, as you can see here. And what that means is they can be cooled by the ocean. And it means you don't need as much power to cool these things down. You can see here that it doesn't need maintenance because there's no oxygen getting into the system either, because they're kind of in a vacuum and it's consistently cooled. And you can also use these for fish and things to create reefs off coastlines. So it's really, really interesting the way we've got to think about technology in an environmentally friendly way. And, you know, this is an example of some cognitive services that we've got, identifying fish, for example, around one of the Natic data centers off the coast of Ireland there. But when we're thinking about the processing that we can do in the cloud and using things like cognitive services, then that's really important as well. And you can start using these today. You know, last year in the big day, and I challenged the people in the audience, and I'll challenge you as well. Look at some of the cognitive services that the providers like Microsoft allow you to do. We've created all of these things. So cognitive services are pieces of software that you can run, which run in the cloud. You don't need to be really fancy programmer. But this one, for example, can tell you how happy you are and how sad you are. It's an emotional API. But you can get ones that find out how old you are, what gender you are. And think about what applications you could make for that. So you can create a mobile phone app tomorrow with an application which can tell how happy or sad somebody is, or how old somebody is, or what gender they are, or convert different languages in real time. So it's really interesting to think about some of these cloud services, because cloud is where an artificial intelligence and machine learning are things you're going to hear a lot about. So start learning today, and we'll share some links at the end of the presentation. But schools are not going to be showing you this. It's very, very new. So you need to pick up this yourself and give it a go. Learn it yourself and actually go online, find some of the courses and start to investigate it. Something else. So you've got your data centers. But, you know, as you know, through Moore's law, storage space keeps kind of doubling. So does CPU space. And we're coming up with different ways to store things. This actually is where we're starting to store some data now. It's a project which we're doing out at the University of Southampton and our Microsoft Research Labs. And it can store vast amounts of storage on your terabytes of data, which can store for thousands of years on glass. So we're thinking about ways we can store things and how that storage can be reused, and also used environmentally. So that's another thing that we're thinking about, is how we store things. No longer are we going to need to store things on USB. We need to store things in a different way. And Microsoft and other technology companies are starting to have to think about the way storage is actually pushing on the requirements. Now, the next thing I'm going to show you is HoloLens and mixed reality. Now, I hope you can hear the video for this. I did the audio for this. I'm going to press play. So this is talking about how we can use mixed reality in the class, at home.
There's no time to waste, you don't want this. This night is coming for you, bang that drum on you. There's nothing else you can do. Watch out, we let it go. Interesting the way that mixed reality is really driving some of the innovation. And it's not only, things start in entertainment like that, but actually when we start thinking about the way that we can really push the boundary with a lot of these tools and technologies, then people start looking in and going, well, how can we use that in healthcare? It's great that we can use that in sport, but how can we therefore put the HoloLens headset on and get mixed reality connecting into us, for example, with remote communities in Australia, or healthcare where you've got a specialist, say a lung doctor, for example, who's based in the US, who can dial into your hospital in Sydney or Brisbane and actually support you in your consultations there. So there's a real interesting use of mixed reality. We've been using a lot of that in the current COVID environment as well in the US, where people want to see the doctor, but they don't want to go into the doctor. So you can use a lot of that mixed reality tools and technologies there. And like I said, if you've got a Windows 10 device, try it now. There's a mixed reality app already in your device. You can also use 3D Paint and put 3D objects in the world. And if you're looking at Xbox and games development and things like that, really try to push the boundaries then with using Unity, using some of our holographic academies, and we put the links at the end as well. But you can create games with that. You can create 3D environments with that. And you can really start to push the boundaries with the things you're doing inside mixed reality and using tools like HoloLens, but even any Windows 10 device. You don't need a HoloLens to develop for that. So really have a look at those. You can see that video again if you want to look at it in a bit more detail. So what's next then? So when we're looking for quantum computing, you might think, well, wow, what's that, Dan? So that's the next thing that we need to kind of start to focus in on. So it's another trend that's important you start thinking about. What quantum computing means, if we're talking about classical computing, you've got binary switches, yeah? So things are either on or they're off. So you either got electricity flowing through something or not. Now, what we're starting to do with quantum computing is then blur those lines, okay, between things being on and off. And what we call that is superposition, where, I know it sounds a bit technical here, but through science, we've started to think about things having two states at the same time, so multiple states. And you might have done some stuff in physics around the Austrian physicist Schrödinger. And what his thought model was that
yes, you got ons and offs in the computer land, as we all know, but what Schrodinger said was actually he created this thought experiment with a cat, and he basically put a cat in a box, and he said, okay, we put a vial of poison in there, and either the cat is alive or dead, and actually it's both. It's in both states, and it's a bit of a thought experiment, and it sounds a bit random. Go and search for it if you want to have a look at it. Really interesting. But what that means, that it was a thought experiment that he posed to his colleagues, and it's quite famous. But it meant the scientists could start looking at really small particles, and they realized that particles, the really, really small particles, could be essentially in two places at the same time at the quantum level. And what that means is, rather than having a bit being on or off, you can have a bit that is on and off at the same time, which means that the processing we can do in the quantum world is exponential. Now, when we look at that, we call that qubits. So you can see here, it's a little grayed out. It's kind of off and it's on. Now, you might think, well, okay, well, that doubles it. But it actually makes it more exponential, because the more bits you add together, the more exponential the possibilities are. And then it becomes really, really interesting what we can do with technology and what those boundaries are going to produce. So let's think about it like this. If I was going to do this maze, right? If I was going to do this in a classical way, let me rewind that animation. If I was going to do this in a classical way, with classical computing, I might go in there. You might be able to see my ink here, but I could go in and I can test all of these different variations of how to get to that light bulb in the minute. And I can draw that in, and I can really try to find my way around that maze, as you can see. And I've got to try each individual sequence one at a time until I eventually manage to find the way to the light bulb. But what it means is, when you look at quantum computing, as you saw in that animation earlier, all of those things happen at the same time, and you can get to that solution much, much more quickly. But that also means it has big implications, like you hear about in the next presentation, around security and things like that. So quantum computing, really, really interesting, and something that we need to really think about in the future. Now, we've started to develop a quantum computer in the University of Sydney. We've called it Station Q, and we're trying to develop that. You've got to code in Q#, which is a language for quantum computing already, so you can download the Q# SDK. But what does it mean for us? Okay, now I'm going to talk over this video again.
Houston, we see you. We have a go. Over.
When we talk about quantum computing, it's a completely different game.
Quantum computing will enable us to solve problems that currently take longer than the lifetime of the universe in seconds, hours, or days.
We completely reconceive the space in which we do computation.
Quantum computing is like going from crawling to going to a different planet. It's different.
It's only natural that we would want to use the world's most powerful device to combat the world's most challenging problems.
We could attack global warming.
Security,
What are the boundaries of machine learning?
fighting diseases. The possibilities of quantum computers are endless. Microsoft has the best and the brightest working on this problem.
It's really happening. Progress is very fast, and we're building a quantum computer.
What the world wants to know is what happens when we turn the machine on.
What problems will be solvable with a computer that computes in 1 billion parallel universes at the same time?
I think when you sit back and think about what skills you need, we've talked about some really high-end stuff today, and introducing you to quantum computing, which is pretty amazing. And we'll share some of those videos to look at them in a little bit more detail. But when we pare it back and think about what skills you need, okay, we've kind of tried to excite you today and look at some of these things coming up and the challenges that we want to resolve. But it's really important for you and for me as Microsoft, as somebody that interviews people all the time, it's important that you bringing creativity to that. You're thinking outside the box. We get lots of young people and young talent into Microsoft because you need to think differently. Quantum computing is new. Artificial intelligence is new. Bring some of the problems with us and work with us to drive some of these things. Now, it's really important. Let me go back to that slide there. Creativity is important. Your communication is important. The way we collaborate is important. Critical thinking is important. And obviously, computational thinking is important. All these soft skills are really, really important for us to really drive some of these things in the future. So I think it sounds like soft skills, which it is, but I think what you need to do is think about how you can develop those with your technical skills at the same time to really drive some of those outcomes. Which takes me to the next quote here from our CEO, Satya Nadella. And I think this is important because this is for adults as well as students in university and schools. As well as all these new technologies like quantum, it's important that you invest in your own skills development, okay? So your own skills are really, really important, and your teachers are not going to be showing you these. Curriculums are not going to be showing you these. There's no quantum, there's no AI, there's no Azure data center work and cloud computing done in the curriculum at the minute. So you need to learn this yourselves, okay? And that's really important. You've got to take control of your own skills development. If you want to create a game for Xbox, don't wait for somebody else to do it. Do it now. Learn how to do it and create it yourself. If you want to use Azure Cognitive Services to create an app that detects autism or can support people with disabilities, then do it now. Learn how to do it. Age isn't a differentiator here. If you're 16, 15, whatever, 70, go. If you've got a good idea, go and use the tools, learn how to use them and drive that, because you're not going to learn it in school. And you're not going to learn that, nobody's going to give that to you on a plate. If you've got an idea, get it done. And that's what we're saying at Microsoft. We're always learning. We get 6 days a year now to learn. They tell us, you've got to take 6 days off work and you've got to actually spend that learning new stuff. Because if we're not learning new stuff and we're inventing it and we don't know how to use it, then we're in trouble. So skills development is really important. Think about that yourself. How are you going to skill outside there? So what I'd kind of like to quickly share here is also what you can go and do, okay, before we open to some questions. So go to learn.microsoft.com, Microsoft Learn, search in your search engine, find our website and find some of that content and learn yourself. There's other online courses like the EDX platform. Search for some of those courses, games development, mobile development, Azure, AI, data science. If you're interested in those things, go and learn them now. All the stuff's available for free to go and get access to. You don't need to go to university to learn some of this stuff. And to be honest with you, lots of universities are very far behind the curve on this because it's so new. There's a holographic academy if you're interested in developing 3D and mixed reality. We've got a holographic academy. Go into your favorite search engine and search for that, the Microsoft Holographic Academy. Go to some of your local meetups of game development. And also one thing I would say, and I always say this, is showcase that. If you're coming for a job with me, I look at your LinkedIn profile, I look at your blog, share what you've done, share your failures and your successes, share your ideas. If you're interested in hardware, do a hardware review, share that, put it on Instagram, really try to drive some of your love for technology using the platforms that are there, LinkedIn, Twitter, blogging yourself, create your own things and share that and connecting with other people. I had a student who was really interested in Surface devices the other day contact me and he said, I've got a brilliant idea. And he actually had this completely different architecture for some of our Surface devices. I brought him into Microsoft and he presented that to our Surface team and our CEO, Stephen Worrell, and we talked about it and talked about his ideas and his thoughts around that. Everybody's open to listening. If you've got ideas, please share those. So we've talked about a lot today. There's a lot of content here that we've kind of mentioned, from quantum computing to cloud computing and the like. So hopefully it's inspired you a little bit to really drive your interest in computing. And I've kind of hopefully opened
up that thought process for you to think about things in the future and think about what things are coming up and how you can start to upskill yourself and increase that tech intensity that you might want to do personally. So Shouju, any questions?
Yeah, absolutely. No, we've got a heap of good questions here. One question that I've seen that's really good actually. Things like quantum computing are often talked about more in the media because they've got like a wow factor or a bit of a shine and gloss to them. But what do you say are some areas of IT that are given little media coverage, but are still among the most important?
Yeah, absolutely. So the session you've got next, what I'm finding at the minute, which is really important, security, huge. People are really trying to nail down security. Identity is a really important one. So, all the security and identity piece is massive at the minute because people want to be respecting privacy, but also making sure that people are accessing things. I can access my work email on my phone. How do I lock that down? Multi-factor authentication, setting up a secure environment so people can innovate and have control, but also do that in a secure manner. So security is a big one. Lots of other things about actually the way COVID has shown us actually the way people can collaborate and work together, the way we do in events like Big Day in a better way now in terms of, I love catching up with everybody last year, but actually this year it saved the carbon footprint of everybody driving around to different events. All of our events are now online. Do we need to fly around? Do we need to drive and catch, trains to places? Can we do things from our homes? The collaboration is another piece of collaboration, security are things that are kind of top of mind for me. And obviously games development as well, that we've seen lots of pushes into there, and cloud and AI are really important as well.
Absolutely. You also, on the topic of cloud, actually, you did mention cloud storage and streaming from the average Xbox or PlayStation and being able to use better GPUs, even though you have maybe an older model of an Xbox.
Yes.
But how does our current internet cope with that? Is that an area that needs to be developed further before we can actually utilize some of those things that you were talking about?
It is, yeah, but there's clever smarts in it, a bit like we're using for Teams now. There's probably people dialing in from certain regional areas in Australia, and you can do two things. Either you can sort out your internet connection on your end compute, or servers can be clever. So you can use AI to work out how fast the routing is, and we've got things like Azure Media Services, and YouTube and Google use that quite a lot as well in terms of the way that they can actually, if you're consuming something on a mobile device, you can actually give people better quality across low bandwidth. So there's lots of ways AI can support that as well as really try to drive the stuff from the server end. So you can say, well, if you're blasting a game down into 4K and you've got a decent connection, then you can really push a lot of data down. But then you can actually use some machine learning to actually pull that back if people are using things on a smaller device or less GPU or lower bandwidth. If you're interested in that, also look at the Microsoft Flight Simulator that's coming out. There's some really good explanations, and we've got a really amazing view of the world on the Flight Simulator game that we've been released imminently. But also for people who don't have big bandwidth, we use AI and machine learning to kind of cut that quality down so you get a good gameplay without you don't lose the gameplay, but you can lose some of the other quality. So there's a couple of answers to that, but there are things you can do in the back end of Microsoft, and obviously the better the internet becomes, the better the services that we provide with are.
Absolutely. Yeah, perfect. We're just out of time, but I'll go for one more quick question because this has been asked a fair few times.
Okay.
What's your do you play Minecraft, or what's your relationship with Minecraft?
Yeah, so I used to be the Minecraft product lead, yeah, and I do play Minecraft, and I used to be in charge of it for Australia. So yeah, I do love Minecraft actually, and we've done lots of stuff with that. You all got access to that if you're in school. You get access to that, the education edition. Yeah, I used to be the product manager. Minecraft's an interesting one. There's lots of flavors of it across multiple devices. Keep playing it. It's really good for your creativity. The education version has got a whole heap of coding you can do in this. You can learn JavaScript coding, Python coding inside there, which is good for jobs as well. So, although it's a game, it's really, really good to drive you on your jobs for the future. So, yeah, and if you've got any questions, you can find me on Twitter, and I'm more than happy to help with that.
100% agree with the benefits of Minecraft there. Thanks Dan for coming on and sharing your insights and your experiences about technology. And I think working at your time at Microsoft sounds like it's offered you a world of opportunity, and judging by all the questions that came in, it sounds like a lot of the students and a lot of our attendees actually want to know more. So cheers for coming on some questions. Thanks. And the questions that we didn't have time for today, and they'll be posted on our website later. If you'd like to find out more about roles in the IT industry, remember to check out the ACS Foundation's career wheel at careersfoundation.com.au. That's careersfoundation, all one word, .com.au. We'd also like to extend our thanks to all the sponsors who've made this virtual Big Day possible, along with our two presenters today, Dan and Norson. We hope you all enjoyed today's Big Day. Next week, we'll be hearing from Greg Booker, the Chief Information Officer for RACQ, and we'll also be hearing from Dennis Pryor from Cybersecurity at Services Australia. The link for the 3rd of June session is on the screen now, but we will also email this link to all your teachers who will share it with you. Don't forget, if you want to re-watch this presentation or previous presentations, they will all be posted on our website today at www.thebigdayin.com.au underneath the Past Events tab. I look forward to seeing you all next week at 11 AM Australian Eastern Standard Time. Until then, stay safe.